Walk toward a window and look closely at your eyes. Not in a filtered photograph. Not under a bright bathroom bulb. Look at them in soft, natural daylight. Now decide what color they are. Brown, blue, green, gray, hazel, amber. That question sounds simple, but human eye color is far stranger than the names we use to describe it. A blue eye does not contain blue pigment. A green eye is not filled with green coloring. And an eye that looks completely black is usually an extremely dark shade of brown. What you see is created by pigment, microscopic structure, reflected light, and dozens of genetic influences working together. In this video, you will identify the dominant color of your own eyes, examine the rings and patterns inside them, and discover why the same iris can look different from one room to another. But we will also separate biology from mythology. Your eyes contain real clues about pigmentation and inheritance. They do not reveal your personality, honesty, intelligence, or destiny. The colored part of your eye is called the iris. At its center is the pupil, the dark opening that allows light to enter the eye. The pupil may look like a black circle, but it is not a black object. It is an opening into the darker interior of the eye. The iris surrounds that opening like a living camera aperture. In bright light, muscles inside the iris make the pupil smaller. In darkness, they allow it to grow larger. But the iris is not a smooth sheet of color. Look closely, and you may see radial fibers, dark spots, lighter streaks, circular folds, tiny openings, or a ring around the pupil. Those features create an individual landscape. Two people may both describe their eyes as brown, yet one iris may contain golden fibers, dark pigment spots, a gray outer border, and a completely different internal pattern. The color is only the first layer of the story. The main pigment involved in eye color is melanin. It is also involved in the coloration of your skin and hair. But the important question is not simply whether melanin exists in the iris. It is how much is present, where it is distributed, and how the surrounding tissue interacts with light. Brown eyes generally contain more visible melanin in the front layers of the iris. That pigment absorbs a large portion of the light entering the tissue, so less light is scattered back toward the observer. With less melanin, more light interacts with the microscopic structure of the iris and returns to your eyes in different ways. This creates a continuous range rather than a collection of perfectly separated boxes. Dark brown can fade toward medium brown, honey, amber, hazel, green, gray, and blue. The categories are useful. Nature, however, does not draw hard borders between them. Brown is the most widespread human eye color family, but the word describes an enormous amount of variation. Some brown eyes are so dark that the pupil almost disappears into the surrounding iris. Under normal indoor lighting, people may call them black. But place the same eye beside a window, illuminate it gently from the side, and the iris may reveal warm brown fibers, copper streaks, or a lighter ring near the center. Other brown eyes resemble chocolate, walnut, chestnut, honey, or polished wood. The difference does not come from separate brown pigments. It comes from variations in melanin quantity, distribution, tissue structure, and illumination. Dark eyes can also contain complex patterns that are easy to miss because the pigment absorbs more light. So when you examine a brown iris, do not look only for its overall darkness. Look for what appears when light reaches it from an angle. Now consider a blue eye. If you could remove blue pigment from it, almost nothing would change, because there was no blue pigment there to begin with. The blue appearance emerges when the front layers of the iris contain relatively little melanin. Incoming light enters the tissue and interacts with microscopic structures. Some wavelengths are absorbed or pass deeper, while shorter visible wavelengths are scattered back more strongly toward the observer. Your visual system interprets that returning light as blue. This is why blue eyes can appear pale under one condition, intensely blue under another, and nearly gray in shadow. The pigment did not suddenly change. The light did. This also explains why comparing eye color from random photographs can be misleading. A camera changes exposure, white balance, contrast, and color processing. Sometimes the photograph tells you as much about the lighting as it does about the iris. Gray eyes are among the most difficult to classify. Some contain very little visible pigment and can resemble pale blue eyes under bright daylight. Others appear silver, steel, blue-gray, or green-gray, depending on the surrounding colors. The boundary between blue and gray is not a perfect biological line. It is partly a human decision. Two observers can examine the same iris and choose different names. A camera can make the disagreement even larger. Cool white balance may push an iris toward blue. Lower saturation may make it look gray. Warm indoor light may introduce green or yellow tones that were not obvious before. So how should you judge your own eyes? Ignore the most dramatic photograph you have ever taken. Examine both eyes in indirect daylight, without flash, colored filters, or heavy shadows. Then identify the dominant color that remains most consistent. Green eyes create another illusion. They do not require a layer of green pigment. Instead, they usually occupy an intermediate region where moderate or relatively low pigmentation combines with the optical properties of the iris. Warm yellow-brown tones from pigment interact with cooler scattered light. Together, the eye appears green. But green is not one uniform shade. An iris may look olive, moss-colored, emerald, gray-green, or green with golden fibers near the pupil. This is one reason green eyes can appear especially sensitive to the environment. A green shirt, blue sky, warm lamp, dark pupil, or surrounding makeup can change the contrast around the iris and influence what the observer notices. The eye itself has not become a new color. Different parts of the same optical mixture have simply become more visible. Green is not a hidden paint. It is an effect created by pigment, structure, and light. Hazel eyes are often described differently by different people because they contain obvious mixtures. A hazel iris may have brown or golden pigment concentrated around the pupil, with greener or lighter tones extending toward the outer edge. From a distance, the colors blend. Up close, the zones become easier to see. Amber eyes are different. They usually appear more uniformly honey-colored, golden, copper, or yellow-brown across the iris, with less obvious green mixing. But once again, nature does not provide a perfect border. Some eyes sit directly between hazel, amber, green, and light brown. That is not an error. It is what happens when continuous biology is forced into a small collection of color names. Instead of asking only, "What category am I?" ask a better question. Is my iris mostly uniform, or does it contain clearly different color regions? That observation may tell you more than the label. Some people carry an even more visible form of variation called heterochromia. In complete heterochromia, one eye has a noticeably different color from the other. In sectoral heterochromia, a section of one iris differs from the surrounding color. In central heterochromia, a distinct ring of color surrounds the pupil, while the outer iris has another dominant shade. These patterns can arise during normal development and remain stable throughout life. But context matters. A color difference that has been present since childhood is not the same as a new change that appears suddenly in one eye. Inflammation, injury, certain medications, pigment changes, or other eye conditions can sometimes alter the appearance of an iris. A new persistent color change, especially with pain, redness, blurred vision, unusual pupil size, or previous injury, should be evaluated by an eye care professional. Beauty and biology can exist together. But a new change deserves attention. You may have learned that brown eyes are dominant and blue eyes are recessive. That simplified model is useful for introducing inheritance. It is not an accurate map of human eye color. Eye color is polygenic. Multiple genes influence melanin production, storage, transport, iris structure, and the regulation of pigmentation pathways. Two neighboring genes, OCA2 and HERC2, have especially strong effects. A regulatory region inside HERC2 can influence how strongly OCA2 functions, changing the amount of pigment produced in the iris. But those genes do not act alone. Many additional genetic regions contribute to the final result, especially for intermediate colors. That is why parents with similar eyes can have children whose eyes look unexpectedly different. A child does not inherit a finished color from each parent. The child inherits a complex collection of instructions. Development then turns those instructions into an iris. Eye color can provide a statistical clue about ancestry. It cannot identify your nationality, tribe, ethnicity, or complete family history. Brown eyes occur across every major human population and represent the most common global pattern. Lighter eyes occur at higher frequencies in some populations with European ancestry, but migration and generations of genetic mixing have carried those variants around the world. A blue-eyed person does not come from one exact country. A brown-eyed person cannot be assigned to one continent. And two siblings can inherit different combinations from the same parents. Your iris contains a small piece of your genetic history. It does not contain your complete identity. Think of eye color as one sentence inside an enormous book. The sentence may be informative, but it cannot tell you the whole story of everyone who came before you, or everything that makes you who you are. Your natural eye color usually remains biologically stable, but its appearance can change from minute to minute. The first reason is illumination. Cool daylight, warm bulbs, direct flash, shadow, and reflected colors send different combinations of light toward the iris. The second reason is pupil size. When the pupil expands, the visible iris tissue is compressed into a smaller area. When the pupil contracts, more of the iris surface becomes visible. The third reason is contrast. Clothing, skin tone, hair color, makeup, walls, and even the white part of the eye can influence how the iris is perceived. And the fourth reason is the camera. Automatic exposure and white balance can transform hazel into green, blue into gray, and dark brown into black. So your eyes may appear to change. But in most ordinary situations, the pigment itself has not transformed. The observer, environment, and camera have changed the image. Now return to the window and look again. First, identify the dominant color of both eyes. Then move closer. Is the iris mostly uniform? Do you see a darker outer border? Is there a golden or brown ring around the pupil? Are there spots, radial streaks, circular folds, or one section that differs from the rest? What you are seeing is not a psychological test. Blue eyes do not prove sensitivity. Brown eyes do not prove loyalty. Green eyes do not reveal creativity. Hazel eyes do not predict mystery or independence. Those claims are stories placed on top of biology. The real story is more remarkable. Your eye color emerged from pigment, microscopic structure, reflected light, many interacting genes, and a developmental process that created an iris unlike any simple color sample. Tell us what dominant color you found, and whether your eyes contain rings, spots, or mixed zones. Subscribe to Body Clues, because the next clue is already visible somewhere on your body. You simply have to know where to look.